Okay, I'd like to welcome everybody to the first ever screencast that I've done with a class present. So if my first hour would like to say hi, go ahead and say hi.
Hi. Hello.
All right, what we're going to go over today is we're going to go over something called Systems of Equations. Okay, this is actually kind of review because all you are doing is graphing. But when you graph systems of equations, here's what you're looking for. We are trying to find a solution for two different equations and that's everything. Now I want to highlight something here for you. I want it to be important to understand we are only finding how many solutions?
Two.
How many solutions?
One.
One solution. What this looks like is a coordinate. Meaning I have one number for x and a second number for y that works in two different equations. And in fact, I'll even underline the word different because they have to be different equations. If they're the same equation, all solutions are the same thing. Okay? So what we're going to do is we're going to get into our toolbox and we're going to create an image page that is going to be a graph of an XY axis on the large scale. We're going to open this. Okay? I may need to change these coordinates so that we can fit our answers. And now what we're going to do, since we're going to do 4 problems, we're going to make this page happen 4 times. So while I'm making this happen 4 times, you need to make this happen 4 times, meaning you're going to have 4 total graphs that you're going to look at. Alright? So let me duplicate this page. I think that's in the toolbox too. Duplicate page. Duplicate page. Duplicate page. And now we're going to go back to our first graph, which is right here. So the first one that I'm going to look at is going to be equation number 1. Y equals 4x minus 2. And equation number 2 is y equals negative 4x plus 6. Okay? Just so we can be very clear here, how about I graph this one in blue, and then I'll graph the second one in red, and we'll kind of highlight our point where they intersect, or our solution, in purple. Okay? So students from my first hour might want to jump in and help with this. What I'm looking for in graphing is the y-intercept. We recall y equals mx plus b. This is my y-intercept. So what is my y-intercept of my first equation?
Negative 2.
So we go to negative 2. Where is the slope located according to y equals mx plus b? It's attached to what variable? X. So this is 4 as a rise. What as a run?
1.
And we know that because this is a whole number. So we rise 4, run 1. Rise 4, run 1. Using the slope, you can also move in the opposite direction, which means we can go down 4, left 1. Down 4, left 1 would be somewhere about right here. We'll just put it on the very bottom of our graph, even though it's a little bit lower. That gives us a good idea. Because this is an equation, we know it has an equal sign, and so that should produce one solid line. Since we're working in blue, this will be the blue line working right there. And actually, I forgot to change the color. Let me go back here, and I'll make this a blue line for you. Okay? So this matches this first equation, y equals 4x minus 2. Our second problem, we said we were going to graph in red. So now let's graph that in red. Y equals mx plus b. Start with the y-intercept at what?
6.
Positive 6, somewhere up here. And then we have a slope of negative 4 over 1. That tells me I rise down 4 because it's negative. And then right 1, down 4, right 1, down 4, right 1 is somewhere around in here. And now I need that red line representing my second equation. And that looks a little bit pink, so let's find a better red. Okay, now that we have that better red, here goes my line. And that's it. Now, I stated before on the previous page that our overall goal is to find one solution of two equations. Hopefully you can identify this using the eyes on the graph. We are trying to find a solution, one solution, an x value and a y value for two different equations. We had two different equations. We have one solution. What is this point right here? Somebody tell me the x value.
1, 2.
1 is the x value, and then we would move up on the y value to 2. And this is our one solution, or this is our system of linear equations. Okay? So that's the first problem on your notes. Looking at the second problem, and I'll try and pick up the pace and get through this a little quicker now. Y equals 1/2 x plus, actually that's going to be minus -1. And my second equation will be y equals negative 2x minus 6. Let's go ahead and graph this since we're in red. Y-intercept, negative 6. Slope is down 2, right 1. I can't go down 2, right 1, but I can move the opposite.
Up 2 and go left 1.
Up 2, left 1. Go again. Up 2, left 1. Up 2, left 1. Up 2, left 1. Up 2, left 1. And the last one would be hidden somewhere here. This creates one line that is a solid line because it's equal to passing through those points. Realize this point's a little bit off because it should be lower. We don't have room on the graph. Doing our second line, y-intercept at negative 1. And then we have a positive slope.
Up 1 over 2.
Up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. Or I could move the opposite direction. Down 1, left 2. Down 1, left 2. Get this box out of my way. Down 1, left 2. Down 1, left 2. Bring the box back to do the line. This line needs to be blue. So, there's my blue line. Where do these points intersect?
Negative 2, 2. Or negative 2, negative 2.
Negative 2, negative 2. And so x value at negative 2, y value at negative 2. Here's the point, or the one solution to the two equations. Negative 2, negative 2. This is our solution. Moving on to the next one. We have y equals 2. And we have x equals negative 6. Okay? We need to graph these as lines first. That means when I'm on this equation or solution, I need to find where x is always negative 6. Here's my x-axis. I go to negative 6. X is negative 6 here. Regardless what my y is, my x is always negative 6. So that's going to make a vertical line through all these points at x equals -6. Here's my vertical line. Moving right there. Okay, need my second line. Now we have y equals +2. Y is +2 right here. And regardless of what x is, y is always +2. Doesn't matter where we go, y is always +2. That's providing the horizontal line right here. So then our one solution here, or the one point where these lines intersect, is at -6, +2, and here is my solution. Okay, moving on to our last one. We have y equals 3/5 x, and we have y equals 6. So we recall y equals mx plus b. Here's my y-intercept. Notice my y-intercept is nothing. That means my y-intercept is 0. Plus 0 back here, so 0 on the graph. Slope is 3/5. So rise 3, run 5. Rise 3, run 5. Unfortunately, I'm going to run off this graph, but it's located somewhere over here.
You're also going to go down 3/5.
And you could go down 3/5, down 3/5, which is going to be way back here. Okay? Next up, I got y equals 6. This is going to be a tough one to graph because y equals 6 is all the way up there. Let me get out my line. Y equals 6. Regardless of x, y is always that horizontal line going at 6. And remember, this should be exactly horizontal, shouldn't have any slope. I know it looks like it's going down slightly, but it's actually horizontal across. I forgot my blue line. So here's my blue line going across here. And then I would be able to locate that point right up here. And this point value, even though it went off the graph, would be at x is 10, y is 6. And I apologize for that going off the graph. I should have changed the coordinates, but I'm trying to beat the bell before class ends. The reason these points are off, guys, is because I was connecting this point and this point, which are not exact, but ideally this line would go through all points. So you might say goodbye to my first hour, or my first hour might say goodbye to you actually in 3, 2, 1.
Goodbye.
And we're going to stop the recording. You may get your assignment and begin.